Let n be the least positive integer such that 168 is a factor of 1134 per n. If m is the least positive integer such that 1134 per n is a factor of 168 per n, then m plus n equals n. At first cut, this looks like a tough question. It is not. Prime factorizes 168. I know it's 24 into 7. Number of hours in a week, which is 2 into 3 cube into 7. 1134 is 2 into 567, which is a multiple of 9. 2 into 9 into 63, which is 2 into 9 into 9, 3 power 4 into 7. I've written this 2 into 3 cube into 7, which is incorrect. I'm sure you guys have spawned it already. It's 2 cube into 3 into 7. Nice. 1134 per n. 168 should be a factor of that. 168 should be contained within this. There are lots of 3s, lots of 7s. Even 1134 per 1 will contain 3s and 7s. That is sitting here. 2 cube. I need to have 3 2s in this number. This number is only 1, 2. So I have to cube this. So 1134 cube is absolutely necessary. Only then we will be able to get a 2 cube, which is important. We'll have lots of 3s, lots of 7s. It's not, this many 3s and 7s are not required, but we need 2 cube, or n is equal to 3. M is the least positive integer such that 1134 per n is a factor of 168 per m. Nice. This is a factor of 168 power m. Right. So 2 cube into 3 power 12 into 7 cube should sit inside 2 cube into 3 into 7 whole power m. You put m equal to 4, 2 power m equal to 1, 2 cube will be contained. 7, put m equal to 3, 7 cube will be contained, but we need 3 power 12. It's like a big number. M has to be at least 12. Minimum value of n minimum is 3, m minimum is 12. The minimum value m plus n is 15. Nice question. Once you prime factorization, just look at the numbers, look at the prime factorization, we are through. Let a, b and m be, m and n be natural numbers such that a greater than 1, b greater than 1. If a power m plus into b power n is 144 power 145, the largest possible value of n minus m. Very, very interesting. So a power m into b power n is 2 power 4 into 3 square whole power 145, or it is 2 power 580 into 3 power 290. First cut, I thought, hey, a should be 2, b should be 3, or b should be 2, a should be 3. And so that is a nice and simple question. Largest possible value of n minus m. Have n as high as possible, m as low as possible. We are through. So I can say this is equal to a could be 3 power 290 and 2 power 580. This is work. N is 580, m is 290, n minus m is 580 minus 290, 290. We have to pause a second. And so we have not been told that a and b are prime. So this number 2 power 580 can be written as 4 power 290. This can be written as 9 power 145. This can be written as 8 power 145. This can be written as 145 9 power 5 whole power 29. So many different combinations are there. A and b need not be 2 and 3 or 3 and 2. Doesn't work like that. Now let's see. We want n to be as high as possible. So it really helps if we put b as 2. That is the maximum value we can go to. N max is 580. Let's plonk n as high. Put it in there. M should be minimum. So I can say, I can think of it as 9 power 145. M could be 145. Or 9 power 5 whole power 29. M could be 29. Or, quite interestingly, I can think of it as 3 power 290 whole power 1. Or M minimum is equal to 1. N max is 580. M minimum is 1. This could go as high as 579. Beautiful question. We're basically taking the lesser of the two primes, stick it under B, maximize n. larger of the 2 prime, but don't really chase the prime. Blanc A as the entire 3 power 290, m will be 1. So 579 is the answer. Let k be the largest integer such that the equation x minus 1 whole square plus 2kx plus 11 equal to 0 has no real roots. If y is a positive real number, then the least possible value of k by 4y plus 9y is right. Doable question. Expand this. This becomes x square minus 2x plus 1 plus 2kx plus 11 equal to 0, which is x square plus 2k minus 2, 2 times k minus 1 times x plus 12 equal to 0. This has no real roots, so discriminant is less than 0. B square minus 4ac is negative, or b square is less than 4ac. 4 times k minus 1 whole square is less than 4 times 12. K minus 1 whole square is less than 12. K be the largest integer such that this works. So k minus 1, I'm thinking about positive integers because that works better. K minus 1 could be 3. K minus 1 should not be 4. 4 square is 16, 3 square is 9. K minus 1 is 3 or k is 4. I don't have to worry about k being minus 2, minus 3 because you're looking for the largest integer. K equal to 4. Y is a positive real number, the least possible value of k by 4y plus 9y. So 4 by 4y plus 9y. 1 by y plus 9y. This is greater than or equal to a plus b is greater than or equal to 2 times a plus b by 2 is greater than or equal to square root of ab. Arithmetic mean is greater than or equal to geometric mean. Positive real number, we can plug in arithmetic mean, geometric mean. We are finding arithmetic mean, geometric mean of 1 by y and 9y. A plus b by 2 is greater than or equal to square root of ab. A plus b is greater than or equal to 2 times square root of ab. 2 times 1 by y into 9y. Square root of 9 is 3. This is greater than or equal to 6. The least possible value is 6. We are using the idea that a plus b by 2 is greater than or equal to square root of ab. Arithmetic mean of 2 positive real numbers is always greater than or equal to geometric mean of 2 positive real numbers. As long as both are positive and real. So am is greater than or equal to gm. We are plugging that idea in and getting 6. The number of coins collected per week by 2 coin collectors A and B are in the ratio 3:4. So A and B 3:4 coins. If the total number of coins collected by A in 5 weeks is a multiple of 7. So this is coins per week. 5 weeks is a multiple of 7. Then the total number of coins collected by B in 3 weeks is a multiple of 24. And so in 5 weeks, let's say this is 3x and 4x, we'll collect 15x, and 3 weeks the number of collected is 4x into 3, which is 12x. And the minimum possible number of coins collected by A in 1 week. So it's 15x is a multiple of 7, so x has to be a multiple of 7. 12x is a multiple of 24, there's already 12 sitting in there. X has to be a multiple of 2, x has to bring in 2. So 2 and 7, x has to be a multiple of 14. So I'm going to simplify this. Let's say A and B, x, 3 into x is 42, 4 into x is 56. This is 42k and 56k. So the minimum A can bring in 1 week is 42 when k is 1. What are we doing here? We're basically saying 15x is a multiple of 7, x is a multiple of 7. 12x is a multiple of 24, x is a multiple of 2. X is a multiple of 7 and a multiple of 2, x has to be a multiple of 14. So x can be written as 14k, 3x is 42k, 4x is 56k. What is the minimum number? 42k minimum can be 42 when k is 1. And that's what we're doing here. Let n and m be 2 positive integers such that there are exactly 41 integers greater than 8 power m and less than 8 power n. Right? Which can be expressed as powers of 2. Okay, nice. So 8 power m greater than 8 power m and less than 8 power n. So 41 integers that can be expressed as powers of 2. Fine. So So this is 2 power something, 41 different values. Nice. Then the smallest possible value of n plus m is nice. So 8 power m and 8 power m, 8 power n. In between these two, bunch of powers of 2 are sitting there. Right? First of all, this is 2 power 3m less than 2 power something less than 2 power 3n. So between 3m and 3n, between say 9 and 36, and some 2 values. Right? So 3m and 3n, how many different values can there be? So let's say we're looking at numbers from say 2 power 9 less than 2 power something less than 2 power 21. How many values can n take? 10, 11, 12 till 21. 21 minus 9 is 12. So there cannot be 12 different values, there can be 11 different values. Nice. So it's a very important adjustment, because otherwise this 41 won't come. When I did this question, I did 3n minus 3m and say 3 times n minus m, how is it going to be 41? It's not 3 times n minus m, it is 3n minus 3m minus 1, because it is in between. It is greater than this and less than that. So now we get quite beautifully 3n minus 3m minus 1 equals 41, or 3 times n minus m is 42, n minus m is 14. What are the smallest values of m plus n? N minus m is 14. All we need to m and 2 be two positive integers, so m could be 1, m is 1, in which case n is 15, 1 plus 15, 16. Done. Once we find the difference, plugging it in is far simpler. Doable question. In a class of 100 students, 73 like coffee, 80 like tea, and 52 like lemonade. It may be possible that some students do not like any of these 3 drinks. The difference between the maximum and minimum possible number of students who like all the 3 drinks is a pain in the neck question. Right? So very tough, very time consuming. Anytime we have maximum and minimum at set theory, we should say, hey, maybe I'll stay a couple of steps away from this. If it's 3 questions or 2 questions, it's reasonable. If it's just 1 and we have maximum and minimum, we find the difference. Fine, not worth it. Coffee is 73, tea is 80, lemonade is 52. Totally there are 100. Simple rule of thumb, add these 3, 73 plus 80 plus 52. Right? If it is less than 100, then life is easy. That means that a lot of numbers here, life becomes super easy. That will generally not be the case. 73 plus 52 is 75 plus 50, 125, plus 80, 205. It's more than twice of this. And so that straight away says, got to be somebody sitting here. This cannot go to 0. Right? Because if you put the numbers here, here and here, each number will get double counted. Even after double counting, it won't hit this 205. Right? So how do we do this? It's a very beautiful algebraic method for this. Call this as y1, y2, y3. Call this number as x. Outside let it be p. Right? Now if I add C, T and L, that is coffee, tea and lemonade. I'm interested in finding coffee union tea union lemonade. This number is 100 minus p. Chances are we'll put p as 0 and then simplify this. But I still want to put p because I said some students do not like any of these 3 drinks. That's given. So 100 minus p. My starting point is add coffee, add tea, add lemonade. I'm going to do that. If I do that, then this gets added twice. This appears in coffee and tea. This appears in tea and lemonade. This appears in coffee and lemonade. And this fellow gets added thrice. And so this 100 minus p, which is coffee union tea union lemonade, should be equal to coffee plus tea, which is 80, plus lemonade minus y1 plus y2 plus y3 minus 2x. I'm subtracting these because they've appeared double. I'm doubly subtracting that x because it has appeared triple. We do minus a intersection b minus b intersection c minus a intersection a plus a intersection b intersection c. We do minus of y1 plus x minus of y2 plus x minus of y3 plus x. X completely disappears. We add x back. Instead of that we can say minus of y1 plus y2 plus y3 minus 2x. Nice, brilliant. 73 plus 80 plus 52 is 205. We already found that out. So 205 minus 100 is 105. So I'm going to write this equation again. 100 minus p is 205 minus that y1 plus y2 plus y3. I'm calling it as y minus 2x, or 2x plus y minus p is 105. What are we interested in? We want to find the maximum value of x and the minimum value of x. So 2x plus y equal to 105 plus p. You can rewrite it like this. And so we want to find a maximum value of x. What can the maximum value of x be? Can we put x as 52? And so 52 into 204 plus 1 is 105. P is 0, is 105. Can x be 52? We put x as 52 here. Y is 1. These two cannot be 1. But I can put 1 here and then solve this entire thing. Remove 52 from this. From 100 we'll remove 52. That will take us to 48. And this 1 goes away. 49. Sorry, 47. These two add up to 47. Should be possible because the entire 52 is taken away. Number is simpler. Should be possible. So x maximum is 52. If I put x as 52, everything works out rather well. I cannot put x as 53 because first of all my lemonade number is only 52. If I put x as 53, y has to be negative. That's not possible. I cannot have y being negative. Right? If I, at the same time, if we put x as 53 and put p as 1, outside as 1, the moment I put x as 53, my lemonade constraint goes off. It cannot be more than 52. With 52, I'm able to work it. I'm through. Done. X maximum is 52. X minimum, it should be as low as possible. Right? For that, the best case scenario is put p as 0. 2x plus y equal to 105. Put x as 0, y should be 105. But look at the diagram. Y cannot be 105. There are only 100 people remain. These three cannot add up to 105. That's not possible. So the maximum we can go is for y to be 100. Put y to be 100, x has to be 2.5. That's not possible. But if you put x as 3, y as 99, y is not 100, but x plus y is 102. That's not possible. This plus this cannot add up to 102. Only 100 people are there. So x cannot be 3 either. So you have to keep in mind that x plus y is less than or equal to 100. If we keep that also in mind, we say, hey, if I keep x as 3, it doesn't work. If I put x as for every 1 unit I increase x, I can decrease y by 2. So after decrease the total by 5, I take x up by 5. X goes to 5. 2 into 5 is 10. Y goes to 95. 2 into 5 plus 95 is 105. X plus y is 100. That can work. Or x minimum is fine. Maximum is 52, minimum is 5. Difference is 47. Long to super tough question. Utterly, pointlessly time consuming question. From an exam context, you say, oh, nice question, beautiful, I'll do it after the exam, leave it and come. And finding maximum, minimum in this context is getting the funda right, getting the idea right, putting the numbers in right, getting the detail right, and getting to the final value right. The whole rigmarole is going to take time. Probably say, hey, nice, but I'm not touching it. F of x equal to modulus of x minus p, plus modulus of x minus 100 plus modulus of x minus a minus 50. Distance between x and a, distance between x and 100, distance between x and a plus 50. The maximum value of f of x becomes 100 when a is equal to. And so very nice. So let's put 0, a, x, 100. And so first of all, the maximum value possible in this function, this is modulus of x minus a, this is modulus of x minus 100 or 100 minus x, either way it won't matter. And then modulus of x minus of a plus 50. From a plus 50 we are subtracting x, or from x we are subtracting a plus 50. And so this is the function. F of x is modulus of x minus a plus modulus of 100 minus x plus modulus of x minus a minus 50. When will this be maximum? For a given a, right? For a given a, this is 100 minus a, be maximum when x is 100, because x minus a minus 50 is remaining, or a plus 50 minus x is remaining, one of these two. And so a plus 50 could be so small that x minus a plus 50 is remaining, or a plus 50 is large but x is even larger. From x to a plus 50, that distance is remaining. That is the remaining distance that we need to calculate. Finally, we need to include distance between x and a plus 50. Nice. This is built in, always equal to 100 minus a. Maximum distance between x and a plus 50, that will be the maximum of 100 plus x. Distance between x and a plus 50 plus 100 minus a is equal to f of x. 100 minus a is this, and this adds up to 100 minus a, right? And distance between x comma a plus 50 plus 100 minus a is f of x. The maximum possible value of f of x becomes 100 when a is equal to. So maximum possible value of f of x becomes 100. So that means distance between x and a plus 50. Remember, a plus 50 could be higher than x, or x could be higher than a plus 50. And so when x is higher than a plus 50, the maximum value would be when x is 100. And so, and a plus 50 is some value, we find that out and come back. When a plus 50 is less than x, a plus 50 is this side, distance between x and a plus 50 is once again when x is 100, when a plus 50 is higher than x, when x is lesser and lesser. Right? That's when this happens. Now, the maximum distance between x and a plus 50, a and a plus 50 lie somewhere, x is more than a, if it is less than a plus 50, I put x at a, that's when that distance will be 50. That's the maximum I can have. Put x at a, distance between x and a plus 50 can be as high as possible. X cannot go below a. So the maximum difference between x and a plus 50 is 50. That's the maximum possible. And so it cannot be more than 50. Because x cannot be less than a, that much we know. A and a plus 50 distance is 50. If x were greater than a plus 50, then we'll have 0, a plus 50, x. Then x and a plus 50 cannot have a distance of 50. Why? Because x, if a plus 50 were 50, x would be 100. That's not possible, because a plus 100 will be more than 100, because 0 less than or equal to a. So the maximum distance, this value maximum would be 50 when x is at a, and a to a plus 50 distance is 50. So this maximum is 50, or when the maximum goes to 100, 100 is equal to 50 plus 100 minus a, or this maximum is when a is equal to 50. When we have a scenario where 0, 50, 100 and x is in between 50 and 100, in that case the maximum value of f of x will be 100 minus a plus x minus of a plus 50, in which case when x is 50, that's when the maximum will reach out to 100. Absolutely delightful question, super difficult, super tough, right? So we have to reframe this. Modulus of p minus q is the distance between p and q on the number line. That's a funda. We grab onto that, bunch of these questions become that little bit more doable, and that's something that we should look to grab onto. Right? 5 students, including Amit, appear for an examination with possible marks in which possible marks are integers between 0 and 50, both inclusive. Average marks for all the students is 38, and exactly 3 students got more than 32. If no student got the same marks and Amit got the least marks among the 5, then the difference between the highest and lowest possible marks of Amit is so nice. So S1, S2, S3, S4, A. Amit is the least. Right? Exactly 3 students got more than 32. these three have got more than 32. Nice. And Amit got the least mark. S4 should be less than or equal to 32. These two are more than 32. Exactly 3 got more than 32. This could be 32. That's the situation we have now. Average is 38. Nice. First we want to find Amit maximum and Amit minimum. Both of that we want to find. Let's think about Amit maximum. S4 maximum can be 32. I want to put S4 as 32. Amit maximum is 31. These three are all greater than 32, greater than 32, greater than 32. 32 plus 31 is 63. Total is 190. Why 190? 38 into 5. From this you subtract 63. 127. 127 broken into 3 parts. Adding up to 127, all more than 32, less than 50. Possible. I put it as 40, 41, 46. It should happen. This is possible. So our Amit max is 31. Nice. That's the maximum possible. It cannot be more than 31. He cannot be 32. This is 32. This has to be 33. It will be more than 32. Only 3 have got more than 32. Amit, yes, maximum can be 31. Minimum. Amit has to be minimum. Everything else has to be maximum, as high as possible. So what do I put? I put this guy as 50. As 49. This guy as 48. And this guy as 32. Add everything up. 2 plus 8, 10, 19, 9, 1, 6 plus 4, 10, 14, 17, 179. Total is 190. These 4 fellows add up to 179. Amit will have 11. So I could have 50, 49, 48, 32, 11. That's a possibility. Or Amit minimum equal to 11. Difference between maximum and minimum is 20. Very nice question. Capture all the detail. Keep in mind that average is 38, so sum should be 190. 3 are more than 32. That means the fourth one is less than or equal to 32. It could still be equal to 32. Amit is the least. If Amit has to be maximum, then S4 has to be as high. The maximum value S4 can take is 32. Amit maximum can be 1 less than S4, 31. Easy. Amit has to be minimum. Other 4 have to be as high as possible. 50, 49, 48, 32 is the best scenario, which makes Amit as 11. 21 minus 11, 31 minus 11 is 20. It's a beautiful question, super challenging. In an examination, there were 75 questions. 3 marks were awarded for each correct answer, plus 3 for correct answer. 1 mark was deducted for each wrong answer. And 1 mark was awarded for each unattempted question, not attempted. Right. Plus 3 minus 1 plus 1. Right. Ryan scored a total of 97 marks in the examination. The number of unattempted questions was greater than the number of attempted questions. This, let's say x, y, z. Z is greater than x plus y. All 3 put together is 75, or z is more than half of it. 38 or more. 37 or less. X plus y could be 37, z could be 38, 38 or more, 37 or fewer. At least 38 questions were unattempted. And that's what we know. Then the maximum number of correct answers that Ryan could have given in the examination total is 97, getting 97 marks totally. So we can say 3x minus y plus z equals 97. We know x plus y plus z is 75. We know z is greater than or equal to 38. This is where we stand. And so there's a beautiful way of kind of tackling this, simplifying this. This is a plus 3 minus 1 plus 1. Generally in our world, unattempted questions are given no marks. So we say 75 totally. Every question you get some mark. That's a given. So I'm going to remove that from the equation completely. I'm going to alter this equation dramatically. I'm saying instead of getting plus 3 minus 1 plus 1, I'm a strict teacher. I walk in and I say for every question I remove a mark. Every question I remove a mark. That is, every plus 3 will become plus 2. Every minus 1 will become minus 2. Every 1 will become 0. Unattempted questions, you get 0 marks. I'm removing a x, y, z totally from it. From this, we subtract x plus y plus z. Algebraically, what are we doing? We're subtracting this equation from this. 2x minus 2y equals 22. Conceptually, what are we doing? We're removing 75 marks. Each question, we are cutting 1 mark. Or the total mark is not 97, it's only 22. You get 2x minus 2y equals 22. 2x minus 2y is 22. Or x minus y is 11. Right? We want the maximum possible value of x. And x plus y can be a maximum of 37. This is a maximum value. X plus y maximum is 37. How do I know that? Because this total z is more than x and y put together. So if x plus y is higher, that's when x can be higher. Add these two. So the maximum value is 2x is 48 or x maximum is 24. We know x minus y is 11. That much we have figured out. We've got. We can figure out now that x plus y maximum is 37. Only if x plus y is higher, x plus y can go to, the higher x can be. Maximum it can go to is 37. 2x is 48, x is 24. X is 24, that gives y as 13. 24 correct answer, 13 incorrect answers, adding up to 37, 38 unattempted. That will give us answer. Or the maximum number of correct answers that Ryan could have given in the examination is 24. 24 into 3 is 72 plus 13. 24 into 3 is 72 plus how much is this? 13 into 1. 13 into minus 1 and then remaining 38 into plus 1 should add up to 97. For some natural number n, assume that 15,000 factorial is divisible by n factorial factorial. The largest possible value of n is so 15,000 factorial. Is it divisible by 5 factorial factorial? 5 factorial is 120 divided by 120 factorial. This works. 5 works. Put a 6 factorial. That means 120 into 6. 720 factorial. This is 15,000 factorial. 1 into 2 into 3 into 4. All the way till 15,000. 1 into 2 into 3 into 4 are 720. 6 is also possible. Put 7 factorial. 720 into 7. 0, 4, 1, 5040. Yep. That also sits within this. 7 should be possible. Put 8 factorial. 5040 into 8. 0, 32. 40,320. 8 factorial will become bigger than 15,000 factorial. So 8 is not possible. 7 is possible. It seems like a very intimidating question. I got shocked when I read this question. N factorial. That we're dealing with very large numbers. We have to figure out something. He's basically saying find the smallest n such that n factorial is greater than 15,000. Our answer is 1 less than that. 8 factorial is more than 15,000. 7 factorial is less than 15,000. Sorry, 7 factorial is less than 15,000. 8 factorial is more than 15,000. That's all we need to find out. And so once we decide to say, okay, let me poke this, I'm not going to get intimidated by this, then this becomes a very easy question. For any natural number n, suppose the sum of the first n terms in arithmetic progression is n plus 2n square. If the nth term of the progression is divisible by 9, then the smallest possible value of n is n plus 2n square. What I'm going to do, sum up to n terms is n plus 2n square. What will I do? I'll find sum up to one term. This is 1 plus 2, which is 3. And sum up to two terms. 2 plus 2 into 2 is 4, 4 into 2 is 8, 2 plus 8 is 10. Sum up to 3 terms. 3 plus 2 into 9 is 18, this is 21. Sum up to 4 terms. 4 plus 2 into 16 is 32. This is 36. Or the first term is 3. Second term is 10 minus 3, 7. Third term is 21 minus 10, 11. Fourth term is 15, and so on. Done. First term, sum up to one term, two term, subtract this minus this, that's the second term. This minus this, that's the third term. This minus this, that's the fourth term. So we've got our sequence. If the nth term of the progression is divisible by 9, the smallest possible value of n is 3, 7, 11, 15 didn't work, 19, 23, 27. This works. 1, 2, 3, 4, 5, 6, 7. Seventh term works. Find S1, S2, S3, S4. With that we have found term 1, term 2, term 3, term 4. With that we know the AP. Write down the AP. One term is multiple of 9. We are through. Juicy question, simple question. For natural numbers x, y and z, if xy plus yz is 19 and yz plus zx is 51, y into x plus z is 19 and z into x plus y is 51. We told very clearly that x, y and z are natural numbers. 19 can only be broken as 1 into 19 or 19 into 1. It cannot be 19 into 1. X plus z cannot be 1. X plus z is 19. Y is 1. Plug that in here. So z into x plus 1 is 51. This is not 51 into 1, x cannot be 0. Not 1 into 51, x is not 50, that we know. 3 into 17, 17 into 3, x plus z is 19. So x, z into x plus 1. So this could be 17 into 2 plus 1. 17 plus 2 is 19, that works. We put z as 3, x equal to 16. Then x plus z is 19, 3 into 17 also works. So we could have a scenario where y is 1, x is 2, z is 17, or y is 1, x is 16, z is 3. So this is 17 into 3 or 3 into 17. Both ways it works. So it adds, it could be z is 17, x is 2 could work, or x is 16, z is 3 could work. Minimum possible value of x, y, z, multiply this is 48, this is 34. Product is lower in this case, which is 34. Lovely, done, through. Let a be the largest positive integer that divides all numbers of the form 3 power k plus 4 power k plus 5 power k. B be the largest positive integer that divides all numbers of the form 4 power k plus 3 times 4 power k plus 4 power k plus 2, where k is any positive integer. Then a plus b. What do? We say we put k equal to 1 and we find 3 power k plus 4 power k plus 5 power k. So 3 plus 4 plus 5, 12. K equal to 2, 9, 16, 25. K equal to 3, 27 plus 64 plus 125. This is 12, 9 plus 16 is 25, 25 plus 25 is 50, 9, 16, 6, 1, 3 plus 6, 9 plus 2, 11, 1, 2, 16. We can keep on going. Right? So the A should be less than or equal to 12. This number is only 12. 12 does not divide this. 12 does not divide, even 6 does not divide. This does not have a 3. It does not have a 4 either. Between these two, the highest common factor is 2. So 2 can divide all of these numbers. Yes, this is odd, add up, it's odd. Add plus odd is odd plus odd is even, even plus even is even. This is an even number. So A can be 2. That part is done straight away. And so A, anything more than 2 is not possible. 4 is not possible, not a multiple of 4. 6 is not possible, not a multiple of 6. Out. Anything else doesn't divide this. So beautiful. So A is 2. Second one is more interesting because there's 4 power k, and there's also 4 power k into something. So we can extract a 4 power k out. We call it 4 power k, 3 into 4 power k plus 16 into 4 power k. Or this is 4 power k into 1 plus 3 plus 16 into 20. Where k is any positive integer. K could be 1, 2, 3. So if we put k as 1, this number is 80. K is 2, this is 320. So the number, any number, k is 3, it will be 320 into 4. K is 4, it will be 320 into 4 into 4. So always it's a multiple of 80, the largest positive integer that divides this. For any k is 80. This number is always a multiple of 80. It is 4 power k into 20. K is at least 1. This gives us a 20, this gives us a 4. So the smallest number, the largest number that will divide this always is 80. K is 1, it is 80. Anything more will be more than 80. And so 80 is definitely in the number. A is 2, B is 80. Add these two, we get A plus B to be 82. F of x is x square minus 7x and g of x is x plus 3. Then the minimum value of f of g of x minus 3x. F of x plus 3 minus 3x. We need to minimize this. This is x plus 3 whole square minus 7 times x plus 3 minus 3x. Let's find this. X square plus 6x plus 9 minus 7x minus 21 minus 3x. This is x square. 6x minus 7x is minus x minus 4x minus 12. Simple completion of squares. X square minus 4x plus 4. This is x square minus 4x plus 4 minus 4 minus 12. This is x minus 2 the whole square minus 16. We want to find the minimum possible value of x minus 2 whole square minus 16. That can happen when x minus 2 whole square goes to 0. The value will be minus 16. Complete the square. Think of it as a square plus a balancing term. We are through. Freebie. Among 100 students, x1 have birthdays in January, x2 have birthdays in February, and so on. x0 equal to maximum of x1, x2, x3 till x12. Then the smallest value possible of x0. So all 100 could have birthdays on January, so x0 could be 100. Technically speaking, x0 could be 90, x0 could be 50. 50 people in January, others being distributed. We want to find the smallest possible. x0 cannot be 3. Because if x0 were 3, x1 to x12, all of them being 3 also, will get a total only to 36. x0 will be lesser. The numbers are as close to each other as possible. 100 by 12 is 8 point something. So you can have a bunch of 8s. 8, 8, 8, 8. 12 8s take us to 96. You could have 8, 8, 8, 8, 8, 8, 8, 8, 8 8s taking us to 64. 9, 9, 9, 9. That will take us to 100. Smallest possible value of x0 is 9. Everything cannot be 8. But if you have a bunch of 8s and a few 9s, this total can be achieved. In which case x0 will be 9. AB is 432. BC is 96. A into B is 432. B into 6. C is 96. They're positive integers. C less than 9. Product is involved. So as much as possible, keep the numbers as low as possible or as close to each other as possible. C is less than 9. C could be 8. 12 into 8 works. 432 is 216 into 2. 2 cube into 3 cube into 2. This is 2 power 4 into 3 cube. Keeping it in terms of prime factorization could be easier. C could be 8, B could be 12. Keep it close. C could be 6, B could be 16. 4 won't work. 5 won't work. 4 into 24. 3 into 32. 2 into 48. 1 into 96 I think is outlandish. Even this we don't need to worry about. It's one of these 4. And whichever one works. So if B were, let's say B is 12, B is 16, B is 24, B is 32. B cannot even be 32. That is 2 power 5. Only 2 power 4 into 3 cube. A, what should A be? B is 2 square into 3. A should be 2 square into 3 square, remaining 36. B is 16. A is 27. B is 24. 2 cube into 3. 2 into 3 square, a should be 18. Lovely. So we have A, B, C. A could be 36, B could be 12, C could be 8. This looks nice. Or A is 27, B is 16, C is 6, B is 24, A is 18, C is B being, A is 18, B is 24, C is 4. One of these is the answer. This is minus 9 plus 4 minus 2. So this is better. Just comparing. Minus 9 plus 8 minus 2. This will be better. 27 plus 16 plus 16 plus 6 is 22. 22 plus 27 is 49. 28 plus 18 is 46. 46 is better. If x and y are non-negative integers such that x plus 9 is equal to z, y plus 1 is equal to z, and x plus y less than z plus 5, then the maximum possible value of 2x plus y equals. So to start with, I like the idea of drawing a number line, which you can plot everything there. There is x, x plus 9 is z, this is plus 9, y plus 1 is z, so y is here. All three are linked. When I started doing this, then I realized I don't even need to draw the number line because all three can be captured with the same variable. Right? So here we have x plus y, which is x plus 8 less than x plus 9 plus 5, or 2x plus 8 is less than x plus 14, or x is less than 6. Lovely. The maximum possible value of 2x plus y, higher x is, higher y will be. We know that they are non-negative integers. X is less than 6. The x can be 5. If x were 5, then y would be x plus 8, 13. 2x plus y, 2 into 5 plus 13. 10 plus 13, 23. That's the maximum. I started off doing this, but I realized that all three are part of the same variable. Becomes a very simple question. For real x, the maximum possible value of x by square root of 1 plus x power 4. These kind of questions, trick 1 in the book. Whenever there's a square root sitting here, see if you can simplify this expression to have some kind of symmetry. What do I mean by that? There's an x on top and then the square root and 1 plus x power 4. 1 and x power 4 are far away and x is in the middle. This is x power 1, x power 0, x power 4. We're all over the place. But if you simplify this, make one very simple change. Divide by x in the numerator and denominator. So numerator is x by x. Denominator is 1 plus x power 4 by x square, because inside the square root. Right? X by x is 1. 1 by square root of 1 by x square plus x square. Lovely. Once you do this, you're through. We've already seen this in a couple of questions. X plus 1 by x is either greater than or equal to 2 or less than or equal to 1 minus 2. 1 by x square plus x square is always greater than or equal to 2. Fine. So I'm going to start with this. X square plus 1 by x square is greater than or equal to 2. Or square root of x square plus 1 by x square is greater than or equal to root 2. 1 by square root of x square plus 1 by x square is less than or equal to 1 by root 2, or the maximum possible value 1 by root 2. The first thing, divide numerator and denominator by x. Numerator gets divided by x, denominator gets divided by x square inside the root. Then modify this. You need to be able to see this expression as this expression. We know how x square plus 1 by x square behaves. Therefore, we know how square root of x square plus 1 by x square behaves. Therefore, we know how 1 by square root of x square plus 1 by x square behaves. So, this is greater than or equal to 2. This is greater than or equal to root 2. 1 by this is less than or equal to 1 by root. It's a lovely question, very challenging question. At least I found it to be challenging. Right? In a group of 10 students, the mean of the lowest 9 students is 42, while the mean of the highest 9 students is 47. For the entire group of 10 students, the maximum possible mean exceeds the minimum possible mean by. And so, 10 students, let's say A1, A2 all the way till A10. Mean of the lowest 9 scores is 42. So I'm going to add up A1 to A9. Sum of all this is 42 into 9. And I don't want to deal with the mean, I want to deal with the total. The 9 entities, so total is 42 into 9. The sum of these 9 is 47 into 9. Sitting here is a very simple, very powerful idea. The sum of the first 9 is A1 through to A9. That is, keeping A1 aside, it is A2 to A9. Sum of the last 9 is A2 to A10, or keeping A10 aside, it is A2 to A9. This bunch is present in both of these sums. And very simple. And so A1 plus this bunch is 42 into 9. A10 plus this bunch is 47 into 9. You subtract one from the other, you can get A10 minus A9. And so I want to write this down differently. A1 plus this total is 42 into 9. A10 plus this total is 47 into 9. This total is everything from A2 to A9. Okay. You subtract one from the other. A10 minus A1 is 47 minus 42 into 9, 5 into 9, 45. Or this number is 45 more than this number. Okay. Now, let's rewrite it like that. So, we have A1, A2, A3 all the way till A9, and this will be A1 plus 45. For the entire group of 10 students, the maximum possible mean exceeds the minimum possible mean by. So, we need to find the maximum possible mean, we need to find the minimum possible mean. Very simple idea. Going from 1, this is one number A1, this is A1 plus 45. And so, quite simply you can say, I want the remaining mean, the lowest the scores will be 42. So, I can have one instance where each of these numbers is 42. And that number will be 42 plus 45. The other extreme will be the instance where each of the last numbers is 47. So, you plonk this as 47, 47, 47. This number is also 47. The first number is 47 minus 45, which is 2. This will represent the minimum, this will represent one boundary, this will represent another boundary. Find the difference in the means, that's the answer you're looking for. And one extreme is when A1 through to A9 are all equal. Another extreme is when A2 to A10 are all equal. Plonk this, find the means and you're good to go. Find the mean in the first case, all of these have 42. So that 42 averages out to 42 plus this additional 45, 45 over 10 instances. So this average will be 42 plus 4.5. Everything has 42. This also has 42 plus an additional 45. 45 over 10 units is 42 plus 4.5. This average is direct 46.5. This one, there are 9 47s or 10 47s minus 45. This average will be 47 minus 4.5. 42 plus 4.5, this is 46.5. This is 47 minus 4.5, which is 42.5. The difference between these two is 4. The choice you're looking for. And wonderful question, delightful question. First, we have to anchor that A10 is A1 plus 45. Then for either extreme, it's going to be put A1 to A9 equal, put A10 to A2 equal. Both extremes get discovered, and then you can find the minimum and maximum. Let's solve this one. Wonderful question, really tough, but there's a very simple, juicy way of doing this. I'm going to do it by the juiciest method possible. I'll give you the starting step for doing the more rigorous method, but not going to get into that. Right? X and y are positive real numbers satisfying x plus y is 102. Then the minimum possible value of 2601 into 1 plus 1 by x into 1 plus 1 by y. Talk about positive real numbers. And the best way to go about it is pick two extremes. Put x is 0.1, y is 101.9, or x is 1, y is 101. Another extreme, put x is 51, y is 51. You're through. Let's do that. Let's put x is 1, y is 101. We worry only about this. 1 plus 1 by 1 into 1 plus 1 by 101. This is one possibility. Or we're talking about 1 plus 1 by 51 into 1 plus 1 by 51. This is barely more than 1, but this is 2. It's 2 into 1 point something. Both of these are barely more than 1. And so this is going to be way greater than this. Or we want to find the minimum possible value. The way to go about it, plonk x as 51, y as 51, both equal. We are good to go. How do we do that? Let's look at that. Put x as 51. So looking at 2601 into 1 plus 1 by 51 or 52 by 51 into 52 by 51. 1 plus 1 by 51 is 52 by 51. 51 into 51, funnily enough, is 2601. 52 into 52, you should find that, but I happen to know that it is 2704. Let m and n be positive integers if x square plus mx plus 2n and x square plus 2nx plus m equal to 0 have real roots in the smallest possible value of m plus n. Have real roots. So b square minus 4ac should be greater than or equal to 0. So m square minus 8n is greater than or equal to 0. 2n the whole square minus 4m should be greater than or equal to 0. Or 4n square minus 4m is greater than or equal to 0. N square minus m greater than or equal to 0. M square minus 8n greater than or equal to 0. Lovely. We've had this. After this, let's not do this algebraically. It's a pain. Find m square is greater than or equal to 8n. N square minus m greater than or equal to 0. From now on, we want m plus n to be as small as possible. We put in our positive integers, you put n equal to 1. Right? Then m square should be greater than or equal to 8. It should be 3 or more. If you put m as 3, then n should be 2 or more. So n equal to 1 does not work. Wonderful. So if you put n equal to 1, it doesn't work, because then both conditions cannot be satisfied. Put n equal to 2. N square is 4. 4 minus m greater than or equal to 0, or m is 4 or lesser. M square minus 8 into 2 greater than or equal to 0. M square minus 16 is greater than or equal to 0. M is 4 or more, or m could be 4. N equal to 2, m equal to 4 works. It just works. This side becomes 0, that side becomes 0. Both times the real roots are equal, but it works. 2 plus 4 is 6. Nothing else will work. That much we know. If you put n equal to 1, it doesn't work. N equal to 2, m is 4, the best case scenario, and it just works. We can confidently mark this. Do not go about this algebraically. Plug in a few values, see where it takes us. What is the largest positive integer such that n square plus 7n plus 12 by n square minus n minus 12 is also a positive integer? It's a delightful question. Anytime you have a quadratic by a quadratic, don't deal with two quadratics, deal with one. How so? Call this as n square minus n minus 12 plus some adjustment term divided by n square minus n minus 12. Brilliant. Now this works. What is the adjustment term? 8n, because minus n plus 8n is 7n plus 24. So this becomes 1 plus 8n plus 24 by n square minus n minus 12. Now let's look at this. If the whole thing has to be an integer, this has to be an integer. 8n plus 24 is 8 times n plus 3. N square minus n minus 12 is n minus 4 into n plus 3. N cannot be minus 3, so this can be knocked off. 8 by n minus 4 has to be an integer. So the best case scenario, this is equal to 1. That's when n will be as high as possible. If you put 8 equals n minus 4, n is 12. N were any more than 12, 13, 14, 15, 16, this will become a proper fraction, a positive proper fraction, and it will not be an integer, or the largest value n can take is 12. Another way of doing this, factorize this, n plus 3 into n plus 4 by n plus 3 into n minus 4. N plus 4 by n minus 4 should be an integer. What is the maximum value n can take? 12 plus 4 by 12 minus 4 works. 16 by 8 is 2. Then you can simplify. The smaller this integer is, the larger value n can take. Put it as 2, simplify, you're through. Let ABC be a right angle triangle with hypotenuse BC of length 20 centimeters. Fine, so BC is 20, A is here. If AP is perpendicular, if AP is a perpendicular on BC, then the maximum possible length of AP in centimeters, the maximum possible length will be when it is an isosceles right angle triangle, when this is 10 root 2, this is 10 root 2, 10 root 2, 10 root 2, this will be half of 20, which is 10 units. Another way of thinking about it, if you draw a circle around this, that's the circumcircle, BC will be the diameter for that. So from here to circumcenter, that will be the radius. Circumradius is 10. If you look at this triangle APQ, the hypotenuse is 10. AP is one of the sides containing the right angle. What is the maximum AP can be? That can be 10 when AP rests on this, or the maximum is 10. F of x equal to minimum of 2x square and 52 minus 5x, where x is any positive real number. The maximum possible value of f of x. F of x is minimum of these two. We want to find maximum value of f of x. Simplest way to do it is to equate this. 2x square equals 52 minus 5x. 2x square plus 52, or sorry, 2x square plus 5x minus 52 is 0. 2 into 52 is 104. This is 2x square minus 8x plus 13x minus 52 is 0. 2x into x minus 4 plus 13 into x minus 4 is 0. 2x plus 13 into x minus 4 is 0. X is some minus 13 by 2, or x is 4. Talking about positive real number, x should be 4. Substitute that. We're talking about x as being minimum value of 2 into 4 square, comma 52 minus 5 into 4. This is 32. This is 32. Or the value we are looking for is 32. Now think about this. I'm going to dive deeper into this minimum idea. 2x square is a graph like this. 52 minus 5x is a line like this. So if f of x is the minimum of these two, we're talking only positive territory, so we completely forget this. F of x would be like this till this point, and then take this. It'll take one arc till a point, and then the other arc after that. This will be the maximum value f of x can take, which is why we find a meeting point of the two arcs. If n and x are positive integers such that n power n is 2 power 160. N is a positive integer, 2 power 160. Key here, we've got to write this as 2 power a number, whole power a number, 2 power p whole power q. Fine, so 2 power p equal to n, which should be equal to q. Fine, so that's the idea here. P into q is 160. If you write this as 2 square whole power 80, this is 4 power 80. That doesn't work. I cannot write this as 2 cube whole power something. I can say 2 power 4 whole power 40. 2 power 4 is 16, 16 power 40. That doesn't work. 2 power 5 whole power 32. 2 power 5 is 32. 32 power 32. Done. So n is equal to 32. It's a roundabout way of saying n equals 32. 32's n square plus 2 power n. 32 square plus 2 power 32 is an integral multiple of 2 power x. 32 square is 2 power 5 whole square. So 2 power 10 plus 2 power 32 is 2 power x into k. Largest possible x. Think about this. 2 power 10 plus 2 power 32 is 2 power x times k. This is 2 power 10 into 1 plus 2 power 22 equals 2 power x into k. This is an odd number. So our number is 2 power 10 into an odd number, or the largest power of 2 that can sit here is 2 power 10, or largest possible x, x max is equal to 10. 4 power n is greater than 17 power 19. I'm going to write this as 4 square power n by 2 is greater than 17 by 19. 16 power n by 2 is greater than 17 power 19. We want to find the smallest n. I want to think about n that doesn't work. If I put n, 16 power 19 is not greater than 17 power 19. 16 power 38 by 2 is not greater than 17 power 19. N cannot be 38. 38 does not work. N has to be greater than 38. So 33 doesn't work, 37 doesn't work, 35 doesn't work. Bam, we've got this. We need to now think that 16 power 39 by 2 is greater than 17 power 19. Fine. It should be, I'm not saying it is not. This is 4 into 16 power 39 is greater than 16 power 19 is greater than 17 power 19. 4 is greater than 17 by 16 whole power 19. This could be tough to prove. It should be. That's what the question is telling us. But we do not have to worry about it. We know that 38 doesn't work. If the 39 and 40 had been in the choices, then we are worried. We are in trouble. It's not. So this becomes an easy question. 39 works. N cube minus 11n square plus 32n minus 28 greater than 0. The smallest integer n. See, n cube is powerful. So if you put 100, or then n cube will kill everything else. These are reasonable coefficients. And n cube is very powerful. So if n cube is positive, n cube is way more powerful than n square, way more powerful than n. So if you put n cube as 7, 8, 9, 10, 11, the larger you take n cube to, the more dominant the cube idea will become. So this is going to become bigger and bigger the higher n gets. And it's a curve that's open-ended. It's going to become larger and larger with increasing n. We can sense that. And there are multiple ways of doing this. One would be to just plonk in a value of n and then go from there. My favorite is probably n equal to 10. This is 1000 minus 1100 plus 320 minus 28. 1000 minus 1100 minus 100 plus 320 minus 28. So this works. Now maybe 9 will work, maybe 8 will work. I would like to skip to 8 and then come back and check 9. If 8 works, then I can go lower. So this is 512 minus 11 into 64 plus 32 into 8 minus 28. So 512 minus 704 plus 32 into 8 this is 256 minus 28. So 512 plus 256 is 867. 704 plus 28 is 732. So 512 plus 256 is greater than 704 plus 28. So 8 works. Already I'm beginning to sense that 7 won't work. When so 8 works, this is this close. So the more dominant n is, n cube is, larger numbers should be higher. 8 works, and 8 is this close, so 7 probably won't work. Let's check it out any which way. So 343 minus 11 into 49 plus 32 into 7 minus 28 greater than 0. Is this true? 49 into 11, 490 plus 49 is 539. So 343, 539, 28, 32 into 7, 7 2s are 14, 4, 1, 7 3s are 21 plus 1, 22. Let's add these through. 3 plus 4 is 7, 4 plus 2 is 6, 567. I have a gut feeling this will be 567. So 7 is equal to 0. 8 works. An increasing sequence. So the smallest integer that works is 8. The other way of thinking about it is substituting small values and seeing if it can something factorize it. So p of x by x minus a remainder is 0. So we can look to factorize this if we can manage to find a factor. So we have n cube minus 11n square plus 32n minus 28. If you put n equal to 1, 1 minus 11 plus 32 minus 28. This adds up to 39, it adds up to 33, doesn't work. 2, 8 minus 44 plus 64 minus 28. 72, 72, yeah, this works. So this number, n cube minus 11n square plus 32n minus 28 is a multiple of n minus 2. We can factorize this. N square goes here, n cube minus 2n square. So minus 9n square plus 32n minus 9n minus 9n square plus 18n. We'll have 14n minus 28 plus 7. Sorry, plus 14. This is 14n minus 28, or our expression is n minus 2 into n square minus 9n plus 14, or it is n minus 2 into n minus 2 into n minus 7. When will this be greater than 0? When n is greater than 7. When n is 7, it will be greater than 0. When n hits between 2 and 7, it will be negative. What happens when n is 1? Very interesting. When n is 1, this 1 cube minus 11 plus 32 into 1 minus 28. 1 minus 11 plus 32 minus 28. This is 33 minus 39, which is minus 6. This doesn't work when n is 1. When n is 3, 4, 5, it won't work. When n is 1, these two are negative, this is negative. All three are negative, it doesn't work. Between 3 and 7, it doesn't work. These two will be positive, this is negative. The smallest integer that will work for is the integer 8. The arithmetic mean of x, y and z is 80, or x plus y plus z is 240. The arithmetic mean of x, y, z, u and v, or x plus y plus z plus u plus v equals 75 into 5, 375. Or u plus v is 375 minus 240, which is 135. Where u is x plus y by 2 and v is y plus z by 2. And then the minimum possible value of x is, what is the minimum possible value of x? So u plus v, so x plus y by 2 plus y plus z by 2 equals 135, or x plus y plus z by 2 plus y by 2 is 135. X plus y plus z by 2 is 120. 120 plus y by 2 is 135, or y by 2 is 15, y is 30. Wonderful. So x plus y plus z is 240. X plus z, then is 210. X is greater than or equal to z. So x is greater than or equal to z. So x is greater than or equal to z. The minimum possible value of x min is 105. The best case scenario is when x is equal to z. When x is equal to z, x will be 105 and z will be 105. Y is 30, u and v, we can find all this. So the minimum value of x is 105. That a1, a2, a3 all the way till a52 be positive integers, that a1 less than a2 less than a3 less than all the way till a52. Wonderful. Remember, this is not even less than or equal to, strictly less than. Suppose their arithmetic mean is 1 less than the arithmetic mean of a2 to a52. Wonderful. So a2, a3 all the way till a52. Let's say they have an arithmetic mean of m. And a1 to a52, the arithmetic mean is m minus 1. a52 is 100. Then the largest possible value of a1 is the wonderful question. So I'm going to think about it like this. a2 to a52, the arithmetic mean is m. a1 comes in. Think about this. If arithmetic mean of a1 also included to a2 to a52, if a1 is also included, and if that stayed at m, then a1 should have been m. Average of 51 entities is m. The 52nd, if that were also m, then all 52 average would be m. That's not the case we have here. The case we have here, the average falls by 1. That means the total should have fallen by 52. The average falls by 1. It's like you've taken 1 from each of these 52 entities. So that tells us our a1 should be m minus 52. Average of these 51 is m, and then you add one more. If that were m minus 52, then from an average of m, you're taking 1 on an average from each of the 52, the average would become m minus 1. The other way of doing this, the more conventional way of doing this, all of these put together, the sum is 51m. 51m plus a1 by 52 equals m minus 1. 51m plus a1 equals 52m minus 52, or a1 is m minus 52. This is the algebraic way of doing this, we know that. The average minus 52 is a1, average of these 51 entities. We want to find maximum value of a1. When will that be maximum? When average mean m should be maximum. We know all the numbers are distinct. We know that there are from a2 to a52 there are 51 numbers. So what is the maximum possible average of 51 distinct natural numbers? Where the largest is 100, or we go 100, 91, 98, 97, 96, all the way till 50. It should be 51 numbers. Average of all this. This is nothing but 100 plus 50 by 2. That will be the average. Average is 75. So the m max is 75. A max is 75 minus 52, which is 23. f1 of x is x square plus 11x plus n. f2 of x is x. Then the largest positive integer n, for which the equation f1 of x equal to f2 of x has two distinct real roots. These two should be equal. Then we have x square plus 10x plus n equal to 0. This should have equal to distinct real roots, or the discriminant should be greater than 0. Discriminant is b square minus 4ac, which is 10 square minus 4n greater than 0. 100 minus 4n greater than 0, or 25 minus n greater than 0, or the maximum positive integer n can take 24. If n were 25, we shall have equal real roots. Anything more than 25, this will have no real roots. If you want two distinct real roots, n has to be less than 25, largest positive integer less than 25, that is 24. Equate these two, get to the quadratic, and then put discriminant greater than 0. Done. A, B, C, D are integers such as a plus b plus c plus d equal to 30. The minimum possible value of a minus b whole square plus a minus c whole square plus a minus d whole square is, remember, all three are positive. Fine. So we need to minimize the difference between a and b, a and c, a and d. And so we can try to have all four numbers as equal, put this as 0, put this as 0, put this as 0, but that's not possible because 30 is not a multiple of 4. Remember, whenever there's a difference, the difference is going to be an integer, so they're all integers, and you square an integer. The larger the difference is, the larger the square is going to be. Now, so we should find a to be as close to b, c, d as possible, and all four numbers to be very close to each other. 30 by 4, 7.5. So a, we should peg it at 7 or 8. All four at 7 or 8. We have 2 7s and 2 8s, this will work. 7, 7, 8, 8. A minus b whole square be 0. A minus c whole square is 1. A minus d whole square is 1. 0 plus 1 is 2. Wonderful. So this looks like this will be the minimum. Let's convince ourselves. Fine. So if the difference is more than 1 anywhere, that just that difference square is going to be 4. So we cannot have 0 plus 0 plus 4 or 0 plus 0. We have one difference being 2. We cannot go lower than this. So all the maximum should be 1. So better than 0, 0, 1, we should look for 0, 0, 0, 1, 1. We should look if there is a possibility 0, 0, 1. A equal to B equal to C, and D being slightly further away. And so 8, 8, 8, 6 doesn't work. 7, 7, 7, 9 doesn't work. 7, 7, 8, 8 is the best possibility, or the least is 2. Done. F of a comma b is f of a into f of b for all positive integers a and b. Then the largest possible value of f of 1. See, f of a into b is f of a into f of b. It's a into b. I'm going to put b as 1. F of a into 1 is f of a into f of 1. Or f of a is f of a into f of 1. Or f of a into f of 1 minus 1 is 0. There are two possibilities here. Remember this. Either f of a is 0 or f of 1 is 1. Either this could be a constant function where f of all values is 0. Then f of a into b will be equal to f of a into f of b. In which case f of 1 will also be 0. Or f of 1 is 1. In which case there are different values possible, but f of 1 is 1. That much we know. The largest possible value of f of 1 is 1. When f of 1 could either be 1 or it could be 0. If the constant function f of a equal to 0, then f of 1 will also be 0. If that is not the case, then f of 1 is 1. The largest possible value of f of 1 is 1. As usual, we're going to speak for a few seconds and let the volume stabilize and the volume be clear and loud and all the rest of it, and then jump in and start solving this. Sum of squares of roots. The minimum possible value of the sum of the squares of the roots of the equation is the roots p and q. The two roots, a quadratic. We want to find the minimum value of p square plus q square. We know the sum of the roots and product of the roots formulae. Sum of the roots p plus q is minus b by a, which is minus of a plus 3. PQ is c by a, which is minus of a plus 5. P square plus q square, we want to write this in terms of p plus q and pq. It will be p plus q whole square minus 2pq. This will be p square plus q square plus 2pq minus 2pq. Or this expression is going to be minus of a plus 3 the whole square minus 2 times minus of a plus 5. Or this is a square plus 6x, a square plus 6x plus 9 plus 2a plus 10. Or this is a square plus 8a plus 19. So now we want to find the minimum value of a square plus 8a plus 19. The best way to do it would be the completion of squares. A square plus 8a plus what would make this a square? Something of the form a plus k the whole square. A square plus 8a plus 16 will work. This a square plus 2ax plus 2ak plus k square. So it should be 4. So a square plus 8a plus 16 plus 3. This is 19. So we write this 19 as 16 plus 3. Or this is a plus 4 the whole square plus 3. The minimum value this can take is 3. That is when a is minus 4. Or the minimum possible value is 3.